Hello everybody, welcome into another lesson. So this will be the last lesson of the complex number series, but in this lesson we are going to use the absolute value of complex numbers, which we learned in the last lesson, to determine if a complex number belongs to the Mandelbrot set or not. So a complex number belongs to the Mandelbrot set if you have some function of f of z equal to z squared plus c. That c is some complex number. That c is your complex number, so it'll always be z squared plus your complex number. Z sub 0 is always 0. It's just always 0, so that'll make your life easier. Z sub 1 equals f of z sub 0. Z sub 2 equals f of z sub 1. Z sub 3 equals f of z sub 2, etc., etc., etc. You just usually go up to 3 values. And the absolute value of those values are smaller than some integer. If that's the case, they don't keep getting infinitely large. They stay smaller than a certain integer value, then, or a smaller natural number value, I should say. That's what the n denotes, a natural number. Then the number belongs to the Mandelbrot set. Now, on the other hand, if the absolute value of those numbers just keeps getting infinitely larger, it just keeps going way up and up, then that complex number does not belong to the Mandelbrot set. And I know this seems like a mouthful, but this was the best way I could explain it. In a minute here, we'll get started with some examples. Alright, so let's go ahead and do some examples. I have about 8 of them. Alright, so let's say we have the complex number. We are given c equals 1. That's our complex number, just the good old number 1. So that means our function f of z is going to be equal to z squared plus that complex number of 1. So we have z squared plus 1. Well, it's important to note that z sub 0 is always 0. Alright, so what's the absolute value of z sub 0? That's simply going to be 0. The absolute value of 0 is simply 0. Can't do anything with that. Now z sub 1 is going to be that f of z sub 0, so that'd be f of 0, which would be that 0 squared plus 1, which would just be 1. Now, the absolute value of z sub 1 would equal the absolute value of 1, which equals 1. Now to find z sub 2, we're going to take what z sub 1 was. We'll take f of 1, which would be our 1 squared plus 1, which is, of course, going to be 1 plus 1, which would equal 2. The absolute value of z sub 2 equals the absolute value of 2, which of course equals 2. Now we're going to find one more value, z sub 3, which would be that f of 2. The f of z sub 2, which is 2. So this would give you 2 squared plus 1. Well, 2 squared is 4 plus 1, then you'll have 4 plus 1, which would equal 5. The absolute value of z sub 3 would equal the absolute value of 5, which we know is just 5. And if we found a z sub 4, you would put in that 5 squared, so you would get 26 and an absolute value of 26. It just keeps going up and up and up. It doesn't slow down or stay under a certain number. It just keeps increasing. So, does not belong to the Mandelbrot set. The complex number 1 does not belong to the Mandelbrot set? That would be the answer. So 1 does not belong to the Mandelbrot set. And I got more. What if this time we are given the complex number c equals -1? So we have the complex number -1. Does that belong to the Mandelbrot set? Well, let's set up our f of z function. F of z, of course, is your z squared plus c. That'd be z squared plus -1, or simply z squared minus 1. Well, z sub 0 is just 0 by default. The absolute value of z sub 0 would equal the absolute value of 0, which is simply 0. Okay, we got that one for free. Z sub 1 would equal your f of z sub 0, which is just f of 0. So that's going to be, of course, 0 squared minus 1, which would just give you -1. The absolute value of z sub 1 equals the absolute value of -1. The absolute value of -1 is just 1. Now, if we are going to find z sub 2, we need to find f of z sub 1, which would be f of -1. So f of -1, you'll put in that -1 to the second power minus 1. -1 to the second power is +1 minus 1, which equals 0. And then take the absolute value of z sub 2, which would be the absolute value of 0, which would just give you 0. And then last but not least, let's find a z sub 3. You can find that by putting in f of z sub 2, which would be f of 0. So that again would give you 0 squared minus 1, which would give you -1. And then you have, let's take the absolute value of z sub 3, which would be the absolute value of -1, which would just be +1. So you notice it keeps alternating between 0 and 1. It never goes over 1. It just equals exactly 1. So if n equals 1, and the absolute value of z of some number, it's less than or equal to 1, it doesn't go over 1, then yes, it belongs to the set. In this case, -1 belongs to the Mandelbrot set, because the absolute value never exceeds 1. So it does belong to the Mandelbrot set. All right. What if we have c equals -i? So c is equal to -i. Is -i part of the Mandelbrot set? Well, set up your function, your f of z. That, of course, is always z squared plus your c. In this case, that'd be z squared minus I. So your z sub 0 is always 0 by default. The absolute value of z sub 0 would be the absolute value of 0, simply giving you 0. Alright, now to find z sub 1, what you're going to do is you're going to put in your f of z sub 0, which would simply be f of 0, which would be equal to 0 squared minus I, which would simply give you -i. Z sub 1 is -i. Now, the absolute value of z sub 1 would equal the absolute value of -i, which would just be 1. So you get an absolute value of 1. Okay, let's find z sub 2. Z sub 2 is simply f of z sub 1, which would be f of -i. That's f of negative I, so you'll put in that negative I raised to the second power minus I. What is negative I to the second power? That would be positive 1. So that would be 1 minus I. That's your z sub 2 is 1 minus I. So now let's find the absolute value of z sub 2, which of course would equal the square root of your a squared, which is 1, plus your b squared, negative 1 squared is positive 1. That equals the square root of 2, which let's get a decimal approximation to see about what it is. What is the square root of 2? It's about 1.41. So square root of 2 is approximately 1.41. Alright, now to find our z sub 3, we're going to take f of z sub 2, which would be f of that 1 minus I. So that's going to equal, of course, our 1 minus I raised to the second power minus I. So what is 1 minus I to the second power? You'd have 1 minus 2I plus I squared, all that minus I, which would end up equaling 1 minus 3I minus 1, which would just give you negative 3I. Alright, so now we're going to find the absolute value of z sub 3, which would be the absolute value of negative 3I, which would just give you 3. Well, notice we still keep steadily increasing. In fact, if you're unsure, you can do a z sub 4. If you're unsure, that would just be f of z sub 3, which would be f of negative 3I. That's going to equal, of course, your negative 3I raised to the second power minus I. So that's going to equal, of course, 9I squared minus I, which is going to equal negative 9 minus I. So that's the complex number. Now let's take the absolute value of z sub 4, which would be equal to the square root of 81 plus 1, which is the square root of 82. Let's take a decimal approximation of the square root of 82. You get approximately 9.06. So you notice for every value of z, the absolute value just keeps on increasing and increasing and increasing. It doesn't stop. So in this case, negative I does not belong to the Mandelbrot set. It does not belong in this case, since it keeps on increasing without end. The absolute value does. This does not belong to the Mandelbrot set. All right, I have about 5 more. Now we have c equals negative 1 minus I. So we have the complex number c equals negative 1 minus I. Is this part of the Mandelbrot set? So set up your function for f of z. That, of course, is always a z squared plus your c, which would be z squared minus 1 minus I. Well, z sub 0 is always going to be 0 by default. The absolute value of z sub 0 is simply going to end up being the absolute value of 0, which of course is 0. Now your z sub 1 is simply going to be your f of z sub 0, which would be f of 0 in this case, which would end up being 0 minus 1 minus I, which would end up giving you negative 1 minus I for the value of z sub 1. Okay, so let's find the absolute value of z sub 1. That's going to equal the square root of your a term squared, so negative 1 squared is 1, plus your b squared, that'd be also negative 1 squared, which would be plus 1. That's the square root of 2, which is approximately equal to 1.41. So that's the absolute value of z sub 1 is approximately 1.41. Now to find your z sub 2, you're going to put in f of z sub 1. Well, z sub 1 was negative 1 minus I. So you'll take negative 1 minus I for your f value. So that'll be that negative 1 minus I raised to the second power minus 1 minus I. Which would turn into, what's negative 1 squared? That'd be positive 1. 2 times negative 1 times negative I, that'd be plus 2I. Negative I squared would turn into plus I squared. Then you'd have minus 1 minus I. So this will turn into, let's see, this would just become 1, let's see, the I squared is negative 1, so 1 minus 1 is 0, minus 1 is negative 1. 2I minus I is plus I. So this will turn into negative 1 plus I. Now let's find the absolute value of z plus 2, of z sub 2, which would be the square root of your a squared, which would be 1, plus the square root of your, plus b squared, which would also be 1, gives you the square root of 2, which again is approximately equal to 1.41. Let's find a z sub 3. Z sub 3, of course, is equal to f of z sub 2, which would end up being f of negative 1 plus I. So that would become, let's see, negative 1 plus I raised to the second power minus 1 minus I. That's going to equal, let's see, negative 1 squared is what? That's simply going to be positive 1. Then 2 times negative 1 times I, that'd be minus 2I. I squared, so that'd be plus I squared. Minus 1 minus I. So this will simplify into, let's see, 1 plus I squared. So that's 1 minus 1 is 0. Minus 1, that's another negative 1. Negative 2I minus I. That's going to be 3I. Alright, so let's find the absolute value of z sub 3. That's going to equal, of course, the square root of your a squared, which is negative 1 squared is 1, plus your b squared, negative 3 squared is 9. That would equal the square root of 10. Let's find about what the square root of 10 is. That's approximately 3.16. So it looked like from the z sub 1 and z sub 2 it was going to hold steady, but once you get to z sub 3, you see it starts dramatically increasing. If I found a z sub 4, I bet you would see it increases even more for your absolute value. So in this case, it does not belong to the Mandelbrot set. So this all means that -1 minus I does not belong to the Mandelbrot set. Alright, let's see here. I got 4 more. We have C equals 2. So we just have good old 2 for our complex number. So set up your f of z function. That's always z squared plus c, so in this case it'll be z squared plus 2. Well, your z sub 0 by default is always 0. The absolute value of z sub 0 equals the absolute value of 0, which is just 0. We got that one for free. Now, to find z sub 1, that's simply f of z sub 0, which would be f of 0. So that's going to be equal to 0 squared plus 2, which would just give you 2. So the absolute value of z sub 1 equals the absolute value of 2, which would just give you 2. Now let's find z sub 2. That's f of z sub 1, which would be f of 2. So you would end up with 2 squared plus 2, which would be 4 plus 2, which would be 6. Well, the absolute value of z sub 2 equals the absolute value of 6, which is just 6. And let's find a z sub 3 for good measure. Z sub 3 equals f of z sub 2, which would be f of 6. So that would be equal to 6 squared plus 2, which would be 36 plus 2, which would be 38. Now the absolute value of z sub 3 equals the absolute value of 38, which would just give you 38. So we notice that the absolute value of each of these values just keeps greatly increasing without end. So this number, the complex number 2, does not belong to the Mandelbrot set. So this does not belong to the Mandelbrot set whatsoever. I got 3 more. Alright. This time we have the complex number c equals -1 plus I. Does c equals -1 plus I, is that part of the Mandelbrot set? So set up your function for f of z. That's going to equal z squared plus c. In this case, that'd be z squared minus 1 plus I. Well, you get a free z sub 0, which of course is always 0. The absolute value of z sub 0 equals the absolute value of 0, which as we know is just 0. Easy enough. Now to find z sub 1, you're just going to take f of z sub 0, which would be f of 0, which would give you 0 squared, so you would just get -1 plus I for your z sub 1, okay? Alright, well, what is the absolute value of z sub 1? That equals the square root of -1 squared, which would be 1, plus the square root of 1 squared, which would be 1, equals the square root of 2, which is approximately equal to 1.41. Alright, now let's find z sub 2. Z sub 2 is f of z sub 1, so that's going to be f of that -1 plus I. So this will turn into, you'll take that -1 plus I, raise it to the second power, then -1 plus I. So -1 to the second power is +1. Then you'd have -2I plus I squared minus 1 plus I. So that's going to see 1 plus I squared is negative 1. 1 minus 1 is 0, minus 1, that gives you negative 1. Then you have 2I, negative 2I plus I, that'd be minus I. So you end up getting z sub 2 being negative 1 minus I. The absolute value of z sub 2 is going to equal the square root of that negative 1 squared, which is 1, plus the other negative 1 squared, which is also 1. So you get the square root of 2, which is approximately equal to 1.41. Now let's, for good measure, find z sub 3. Z sub 3 is equal to f of z sub 2, which would be that f of negative 1 minus I. So you'll put in that negative 1 minus I, raise that to the second power, then minus 1 plus I. So negative 1 to the second is positive 1. Then this would be plus 2I. And then you would end up having plus I squared minus 1 plus I. So this is going to turn into, let's see, I squared is negative 1, so 1 minus 1 is 0. Minus 1 is another negative 1. Then you end up having 2I plus I is 3I. So you end up having negative 1 plus 3I. Let's find the absolute value of z sub 3, which is going to equal the square root of that negative 1 squared, which is 1, plus 9, that 3 squared, which is 9, equals the square root of 10, which is approximately equal to 3.16. Notice that finally, once you reach z sub 3, the absolute values start to increase without end, meaning negative 1 plus I does not belong to the Mandelbrot set. So negative 1 plus I does not belong to the Mandelbrot set. And I got two more. All right. Now this time we just have c equals negative 0.5. C is equal to negative 0.5 is this part of the Mandelbrot set. So let's find f of z, which of course is equal to z squared plus c, so that'll be z squared minus 0.5. All right, well, z sub 0 is always 0 by default. So the absolute value of z sub 0 would equal the absolute value of 0, which would just be 0. That's an easy one. Now z sub 1 is equal to f of z sub 0, which would just be f of 0. Well, 0 squared is 0. You just end up getting negative 0.5. So z sub 1 is negative 0.5. Let's find the absolute value of z sub 1, which would be the absolute value of negative 0.5. That absolute value is 0.5. Okay? Now let's find z sub 2, which would end up being f of z sub 1, which would end up being f of negative 0.5. That would equal that negative 0.5 raised to the second power minus 0.5. What is negative 0.5 to the second power? Same as negative 1/2 to the second power. That'd be positive 1/4, so that'd be 0.25. Then minus 0.5. That would turn into negative 0.25. So z sub 2 is negative 0.25. So to find the absolute value of z sub 2, you're going to have the absolute value of negative 0.25, which would end up being positive 0.25. All right, and then we'll find a z sub 3, which would be f of z sub 2, which would be f of that negative 0.25. Which, that's negative a fourth squared. Let's just turn these into fractions for a minute. Negative 1/4 squared minus 1/2. That's going to equal positive 1/16 minus 1/2, which would equal 1/16 minus 8/16, which would be equal to negative 7/16. Well, what is negative 7/16 as a decimal? Negative 0.4375. All right, let's find the absolute value of z sub 3. That's going to equal the absolute value of negative 0.4375, which of course would be 0.4375. Do we notice a pattern here? Your absolute values don't really get any bigger than 0.5, but the nearest integer is, the nearest whole natural number is 1. So all of your z sub a's, which mean all your absolute values, are less than 1. So this belongs to the Mandelbrot set. This one does belong. Since they are all smaller than a fixed natural number and don't increase infinitely, and actually fluctuate between increasing and decreasing, but they never get bigger than 1, c equals negative 0.5, so negative 0.5 does in fact belong to the Mandelbrot set in this case. And I got just one more, then we're done. All right. Now, what if c equaled 0.5i? So the complex number in question this time is 0.5i. Does it belong to the Mandelbrot set? Well, set up your function of f of z. That's always z squared plus c, so z squared plus 0.5i. That's what we have to determine. Well, start out with z sub 0, which always has a default value of 0. The absolute value of z sub 0 equals the absolute value of 0, which just equals 0. Well, that's great. Now, to find z sub 1, you take f of z sub 0, which would be f of 0. Well, 0 squared is 0. You would just simply end up getting 0.5i. So you get 0.5i. So the absolute value of z sub 1 is just going to equal that 0.5, okay? So that's as far as we've gotten. Now, can't we, all right, so z sub 2, of course, is equal to f of z sub 1. That would equal f of the 0.5i, which would mean, why don't we turn that 0.5 into a fraction? So this would end up being 1/2 times I raised to the second power plus 0.5I. So that's going to end up equaling, of course, 1/4 I squared plus 0.5I. Which would be, yeah, that's fine, which would end up giving us, we need to find the absolute value now of z sub 2, which would be equal to the square root of, let's see, 1/16 plus 1/4, which would equal, of course, the square root of 5/16, which would be equal to the square root of 5/4, which, let's see what that's approximately equal to. See what we won. Approximately equal to 0.56. The absolute value of z sub 2 is approximately equal to 0.56. And of course, you know, we got to find a z sub 3, right? Which would be f of z sub 2. Z sub 2 was that 0.25. That'd be actually negative 0.25 I. No, negative 0.25 plus 0.5 I. I should probably expand that, right? Negative 0.25 plus 0.5 I. This one's a bit of a doozy. So anyway, let's put that in. You'll end up getting, of course, negative 1/4 plus 1/2 I raised to the second power plus 0.5 I. All right, so what is, let's see, negative 1/4 squared, that's positive 1/16. Now, let's see, 2 times negative 1/4 times 1/2 I, that'd be 2 times negative 1/8, which would be negative 1/4. That'd be minus 1/4 I. Then you would end up getting plus 1/4 I squared. And then you would end up having plus 1/2 I. So that looks like a long, painful one. Let's start with your real number. So 1/16, and then you have 1/4 I squared. That'd be minus 1/4. So you'd end up having 1/16 minus 1/4. Then negative 1/4 I plus 1/2 I would be plus 1/4 I. Which would end up being, let's see, 1/16 minus 4/16, that'd be negative 3/16 plus 1/4 I. Now let's find z sub 3. Z sub 3, the absolute value of it rather, is the square root of that negative 3/16 squared. That'd be 9/256 plus that b squared, which is 1/4 squared. That'd be 1/16, which would end up equaling the square root of, let's see, so 16 times 16 is 256, so that'd be square root of 25 over 256, which would end up equaling 5 over 16. Well, what is 5/16? I know it's definitely less than half. That'd be 0.3125. Now, do we notice a pattern here with these absolute values? They never go over 1, right? Never. So we can say the absolute value of any of these z sub a is less than n equals 1. So this belongs to the Mandelbrot set. So 0.5i does belong to the Mandelbrot set, since the absolute value never exceeds a natural number. It never exceeds a certain value. Now, if it just kept increasing and increasing, it wouldn't belong. But it does belong in this case because your absolute value never goes over a certain integer value of 1. And sometimes you could have it up to 2 or 3, but it should stay right under that number, never actually exceed it. It should never exceed it. And you only find that number once you notice the pattern of what your absolute values are. It's safe to say it just stays under 1. So that's it for this lesson. Next lesson, we are going to solve quadratic equations by method of completing the square. And from this point forward, we're going to start considering the whole set of complex numbers as our solutions. So that'll come into play when we solve these quadratic equations as well. So I hope everyone has a great day. Take care.